All right, so let's consider a few algorithms that we have already discussed in the tutorial, and I'll just be writing the algorithms here. Okay, so this part is about, once again, stacks and queues. And the first thing here is how to implement a queue using two stacks. So all right, so in a queue, what really we cared about? So the is empty queue, whether the queue is empty or not, whether the queue is full or not, that really does not change. Okay, so that's not the important part here. The important part is the two queue operations, NQ and DQ, right? You have to be able to implement that using the pop and push operators of the two different stacks. Is that okay? So what do we start? So assume that there are, just a second. So let me just change the setting. All right, so assume that there are two stacks. Let's call them S1 and S2. This will be the name that we will use within our algorithm. Okay, so two stacks. We will now form a queue which we call capital Q. Okay, so what are the algorithms that we need to write? Once again, as I mentioned, Q dot is empty, Q dot is full. Okay, uh, the full and empty checking algorithms are exactly the same as what we have seen before, so we will not repeat that. The only other two operations here that we have in the queue are NQ and DQ, if you remember, right? So if you don't remember, just go back to stacks and queues and revise this. Okay. The two other important operations are NQ and DQ. So we have to now write the code for NQ and DQ using the pop and push operators of the stack. That's all. Okay. So let's begin with the first one. So let's write it for NQ. So NQ, Q, and I have to enter the element A, right? And then if you remember, as before, we have start and stop, and then we continue. Okay, so let me just write down NQ operation. Okay, so we have start and stop. So what really are we supposed to do here? So there are two stacks. What will we assume? We will always assume that we are always inserting element into stack S1. Okay. See, the queue is formed using the two stacks. So when the element is stored inside the queue, it is essentially stored in one of the two stacks, S1 or S2. We will assume that it is always stored in the stack S1. Okay. I know that is a problem. So now, what do we really do here? So what we will assume when we are doing NQ, we don't do anything. Okay. So this is simply S1 dot push, or rather just push S1 comma A. Okay. That's all. This is how we are going to form it. The pushing will always happen into the stack S1. S2 is what we are going to use in order to manipulate the entries so that the pop operation works well. Okay, so we'll simply push into S1, nothing more. Very, very simple. Right? But then the structure of DQ will change. So what is DQ operation? So DQ queue. Now we cannot simply pop from S1 because, for instance, if you have just inserted the element A into the queue, popping S1 will just push out the element, pop out the element A itself. That is not what we want, right? There are also other elements in S1 already. And in a queue, what is the philosophy? The one that entered first should leave first, right? First in, first out. Whereas in stack, it is last in, first out. So A, when you enqueue the element A into the queue, A was the last element to go into the stack. So that will be the first element to pop out of the stack S1 if we just pop S1. But we want it to be the last element to fall out of the queue because it's first in, first out. Okay, first in, first out also means last in, last out. Right? So we cannot do this right away. What we have to do is we have to now make use of the stack S2. The stack S2 is used only when we need to DQ. Otherwise, the stack S2 will remain empty. Okay, so stack S2 at this point is just empty. It does not contain anything. The elements inside the queue are always present inside the stack S1. Okay, what do we do now? In order to remove the element according to the queue operation, we just have to reverse the order of all the elements in the stack S1 and then pop out. Okay, just try drawing a diagram and checking. The last element went in the stack S1, but now you don't want to pop it out. You want to pop the very end element from the stack. So you have to reverse the order of all the elements in the stack. How do you reverse the order? You reverse the order by one moving elements from S1 to S2. Try drawing a diagram and checking. You have to move the elements one by one from the stack S1 to S2. Okay, so how do we do that? So we'll do that using a while loop. So while let's call it S1 dot sorry, I think the name of this was stack non-empty, but check. Okay, whatever it is, whatever is a name for checking whether a stack is empty or non-empty, that is exactly the name that we're using here. Okay, so I'm calling it stack non-empty S1. It might be different, but you can just check. Okay, so while stack non-empty is equal to true, okay, as long as this is true. Okay. As long as there is an element in the stack, you pop the element from the stack and push it into the stack S2. Okay, so what are we doing? We are pushing the element into stack S2, but which element? The element that is popped out immediately from S1. Okay, this reverses the order. Okay, so if the stack from bottom to top in the stack S1, if the elements were 1, 2, 3, 4, 5, when you do this at the end of it in the stack S2, the elements will be 5, 4, 3, 2, 1. The orders have gotten reversed. All right, and that is exactly what we want to do. Because now when the orders have gotten reversed, the element that was at the bottom of the stack S1 is now at the top of the stack S2. But the element at the bottom of S1 was the element that first entered the queue. Now it is at the top of S2. So you can just pop S2 and that will be equivalent to removing the element from the queue. Okay. So now what you simply have to do is pop S2. That's it. That is a DQ operation. What else do we have to do? We do have to do a little bit of maintenance, okay? Because we have to maintain the structure. The element has been popped, but we still have to maintain the structure so that when we do any further NQ operations, things don't go wrong. Okay. So now we will do this backwards. We will again remove all the elements from S2 and put them into S1 so that we are back to the original state. Okay. So now once again, while, but now stack stack non-empty S2 is true, what do we do? The same thing. We now move elements from S2 into S1. So push into the stack S1 the elements that are in S2. And we do this until the end. So anyway, okay. That was just to maintain the structure. So the DQ operation actually ends here, but we need to do these additional operations just to make sure that the further NQ operations will not have any problem. Okay, the structure is maintained. So that's it. That is it about the NQ and DQ operations. So I should have just written this separately. So this is DQ operation. Okay, that's it about NQ and DQ operations. Now what is remaining? We have to do the reverse. Okay, the reverse thing is what we need to check. Implement. So we have implemented a queue using two stacks. Let's implement a stack using two queues. Is that okay? So once again, one of the two operations will be essentially the same thing, and we will use the other one for the other operation. Okay. So we have push and pop operations, right? So let's write push operation. So again, push operation remains basically the same. So okay, instead of this, I should write this. Assume there are two queues, Q1 and Q2, and just as before, we will form a stack S. Okay. So now push S comma A. Okay. Now what are we assuming? Again, as before, we will assume that the elements of S are in fact the elements in the Q1. Okay. The elements stored in S are exactly the elements stored in Q1. Is that okay? So stop. And what do we have to do here? Nothing really. This is essentially equal to just the NQ operation Q1. That's it. Okay. But when we have to pop, we have to be more careful. Right? So while we have to pop, what will we do? Something very, very similar. Okay. So now pop operation. It's very, very dual if you think about it. Okay. Very, very similar and has a very similar structure as what we saw in the other case. So start and stop. Once again, we have to check whether something is empty or non-empty, and that part remains the same. Okay, whether the stack is empty or full or non-empty, those operations are exactly the same. So I will not bother about it. Okay, what do we do now? So any guess? So here's the thing now. Now you cannot simply do DQ until it is empty and then NQ it into the other queue and then DQ. That will not work because both the queues are working in the same order, right? Whatever enters first leaves first. That is the way of DQ. Is that right? So we have to DQ the queue only until the last element is remaining. Okay, the last element is the one that has been popped out. So we have to DQ until the last element is remaining. Is that okay? So what do we do here? Here, while q1 dot length is greater than 1, okay, as long as you have more than one elements, we will move it to the other queue. Okay, so it will be nq into the queue q2. What element? The element from the corresponding element by dq in q1. So dq q1. Is that okay? We'll keep doing this. And why? What happens at the end of this? At the end of this, q1 dot length has become 1. That is when the while loop stops. q1 dot length has become 1. There is only one element left in q1. That was the last element of the queue, right? The element that we have just entered into the queue. And that is the one that has to go out because that is how the stack works, last in, first out, right? So now this last element is what we will remove. So now we will dq which element? That element, whichever is remaining in q1. That's it. Okay, that is the pop operation. And now what do we have to do? Now once again comes the maintenance, right? We have to still preserve the structure as it was. Okay, so we have to bring all the elements back into the queue. So now we'll simply say while q2 dot. Now we don't have to bother about length. We have to flush out remove all the elements and move it to the q1. So q2 rather sorry q non-empty q2 equal to true. We will dq from q2 and nq into q1. So nq into q1, the element that you get by dq from q2. Okay, so all the elements from q2 you move it back into q1, and that will preserve the structure for the next pop or push operation that you want to do. Is that okay? So as an exercise, just draw some columns or a row, the diagrams for stacks and queues that we have seen so far, and take some examples and try working out this algorithm over those stacks and those queues. Just see how this algorithm works over those examples for a better understanding. Okay, so that was all about implementing a stack, implementing a queue using 2 stacks, and implementing a stack using 2 queues. Is that okay? So yeah, that's the end of this video, and we might discuss some more things later on. All right, so we'll stop.